Piezoelectric flooring. Everything that's going to be covered in this video is what even is piezoelectric flooring, why it matters, data and numbers that support our claim to use piezoelectric flooring, the triple bottom line, and the VT climate action or CAC contributions, and 2 to 3 things that we'll leave you guys off with. First, what is piezoelectric flooring? What is piezoelectric flooring? Piezoelectric flooring uses the innovation of piezoelectricity, which is electricity from pressure, and it uses materials such as quartz and ceramics, which have a property that creates a small charge of electricity when mechanical stress is applied on them. How it would work would be converting small electrical charge that is then sent to devices can be stored onto batteries, and it is very renewable as it uses wasted kinetic energy from walking, and is very versatile as it can be implemented into buildings, sidewalks, pavement, and indoor and outdoor. How they work? So it's a top tile that is of a harder material, more durable, and then underneath is a vibrating plate that would then be pressed down onto a weaker, softer material that can transmit the vibrations onto the piezoelectric material, which would then be pushed into a circuit, and the charge that is created from the material will be captured. Why it matters.
We compared the 2 best tile options, Pavagen at 3 joules per step, and newer academic tiles at half a joule per step. With about 10 tiles in a busy VT entryway, with about 10,000 to 20,000 steps a day, we generate roughly half a kilowatt hour to 6 kilowatt hours per year. That's not enough to power a building, but it is enough for small loads like LED signs, sensors, or a display showing real-time energy from student footsteps. Placing the tiles in high-traffic indoor areas like the library or dining halls gives the best data and the most visibility. So the big challenge here is that each step doesn't make a ton of energy. Even with thousands of steps, the total is still pretty small. On top of that, the tiles are pricey because that technology is still new. And there isn't a ton of long-term data about how they hold up over time. And if they're outdoors, weather definitely beats them up more, which means more maintenance. But the cool part is that because this tech is so new, it's only going to get better and cheaper as more people start using it. VT could actually be a part of the early wave by doing a small indoor pilot. We get our own campus data, support future research, and have something super visible that students can interact with.
The VT UMP contributions and CAC contributions.
The piezoelectric floor fits the sustainability with visible innovative energy technology, and it fits the goal of campus as a living laboratory. And it can be put in a small-scale pilot on tile upgrade. And the infrastructure need to be changed, our electrical system and floor reinforcement. And it can connect with the bus station and collect the energy only when the buses come.
Some considerations for the triple bottom line are socially. The piezoelectric tiles encourages people to exercise, and it also allows people to feel good because the simple act of walking helps to provide energy sustainably. For the economic aspect, the tiles are $200 to $300 per square meter, which are nearly double the cost of solar panels. And depending on the location, it requires more cost to mitigate wear down from things like the weather. And for the environmental aspect, it uses a resource that's abundant on campus, which is footsteps, and converts it into renewable energy.
Here are 3 key points to remember about piezoelectric flooring. First, this is still a new technology. It isn't widely used yet, but as it becomes more common, the performance will improve and the cost will decrease, so there's a lot of potential for growth. Second, piezoelectric flooring encourages engagement. People can contribute to clean energy just by walking, which makes sustainability feel more interactive and visible compared to other renewable systems. And third, it is very space efficient. Unlike solar farms and wind turbines, it uses surfaces that already exist in cities and on campuses, so it does not take up extra land.